Welcome back from your break, folks. Hopefully you've had a chance to have a wander around Gathertown, meet some of our amazing sponsors, get yourself something to eat, something to drink, and are now ready for your next talk. Are you ready? I said, are you ready? I don't know why I'm doing all that stuff. I can't hear what you're saying anyway, hey? Your next speaker is Matteo, coming to you from Forlì in Italy. Matteo is the technical director of Nearform, as well as being a Node.js TSC member. In this session, Matteo is going to be talking about increasing your HTTP client throughput, and he's going to be presenting a brand new HTTP client that he is releasing out into the wild. Don't forget, post along on social media using the hashtag CityJS2021, as well as keep those comments rolling in on YouTube. Matteo, it is over to you.
Hi everyone, I'm Matteo Collina and today I'm going to talk to you about HTTP. Now, first of all, please follow me on Twitter at Matteo Collina. I talk about Node.js, JavaScript, open source. I complain a lot really about open source most of the time. I don't know. Well, you see. Please follow me. I'm also, my DMs are open, so if you have got any questions or anything that you would like to know more about Node.js and HTTP Fastify, a lot of questions, just please hit me up. I work for a company called Nearform. I am a technical director and we are hiring. So check out our careers page if you are interested. So a little bit about myself. I am a member of the Node.js Technical Steering Committee and I'm co-creator of Fastify and Pino. Fastify is a web framework and Pino is a logger, really fast. I have been doing software architecture for the last maybe 10 years. So hey, here I am. I help companies shipping up great software essentially. So a couple of things about me. This is actually important because I got 6 billion downloads last year, which is, well, an impossible number, to be honest. You know, there's some days it went over 30 millions or something. I don't know, whatever. My software gets downloaded and used a lot. And so I spend a lot of time maintaining things in the ecosystem and maintaining Node.js. This is possibly one of the reasons why I need to keep a balance, right? I need to maintain my ecosystem, maintaining Node.js as the ecosystem, as well as I work as a consultant for a professional services company, and where we help building fast and scalable Node.js applications. So this keeps me always on balance between those two, right? It's a never-ending dance, and this is part of what I do, and this also creates some unique consideration for me to evaluate certain part of our stack. Um, so, going back to the question about HTTP, it's one of the key problem about HTTP is that one of the key thing about HTTP is that it's typically used to talk from the client, typically a web browser or an app, to the cloud where our servers lives. So the nice little dance. And this is a typical monolith application. However, whenever you need to scale up your and your team, let's go back one step. I ended up writing a new web framework for Node.js. It's called Fastify. It's very nice and easy to use. It's also been downloaded 850,000 times per month. It has 16 collaborators and it has more than 160 plugins. It's really great. You should try it out. I wrote this to develop Node.js servers because we needed some new alternative that was fast and easy to use and use the latest part of the spec. It also have native TypeScript support if you are into these things. However, if you want to scale up your teams, you might want to do something different. Why? Well, because a monolith does not take you that far. You might want to move your system into a world of microservices where the client go to the cloud and talk to some sort of gateway that connects to several microservices. This is simplistic, because the reality is that you ended up having some sort of a network of microservices that talks to each other to deliver the response that are needed to your clients. So the complexity here can actually scale pretty badly. Like this can get very complex very quickly. So the focus of this talk and why I started doing some research on this, it's on those links between the microservices. So those are critical for the performance of your application in both container deployment or Lambda or anything. To be honest, why is this? Well, if you from the gateway, if you need to talk to a microservice and then another microservices, you have adding latency at each hop. Like the hop itself is not free, right? So we might talk about 10 milliseconds, 20 milliseconds to do that call. It has some overhead, right? We are serializing a request and deserializing it down on the other side. So all of this takes time. And we want this approach, it works really well if those links are at negligible latency and effort to process those calls, right? So, um, uh, however, a long time ago, I was being asked, how can we speed up the link between microservices? How can we speed up? How can we improve the performance of that network? Why that was a problem? Well, I don't know. There was very hard to that application was hitting the HTTP links really hard, and it was somewhat of a problem for them. So I started researching this problem. So let me show a little bit of my research. So let's consider a very simple HTTP server with create server does require HTTP, and where we actually have a port and a timeout. What are we using this timeout this? Well, this is a very simple. We're basically waiting for a number of milliseconds before before sending a response to simulate some latency on the server. Otherwise, it's going to be all synchronous and it's going to be a little bit problematic. So this is actually a very important part of this experiment. And then we started doing HTTP calls with an HTTP client using the Node Core HTTP, so which is a required HTTP. And this thing, it does an HTTP.get, which is a GET request, and it calls localhost over HTTP with a method of GET and a path of slash to the port. Nice. So that's what we have been doing. This code is, to some extent, it's really reliable. It creates a new HTTP connection for each one of those requests. Wow. Why is it reliable? Well, because it creates one new socket, right? So there's nothing that can go wrong. There's no reuse. However, this is also not really performant because it's a new TCP socket. We'll see that in a moment why that's the problem. So let's go and talk a little bit about the TCP Three-Way Handshake. By the way, these pictures were taken from the High Performance Browser Networking book of Ilya Grigorik. So that's it. It's taken here, and it's you can find it over there. And so you have a sender, and when it starts the TCP three-way handshake, when you create a new TCP socket, it sends a SYN packet, and it needs where it needs to, and then it returns a SYN ACK containing that part. Now, all of these, if you have there is a 20 millisecond latency between those two bits, which is not impossible, okay? It means that we need to, before we send any data, it's taking us these bits. Now, if in case of an HTTPS connection, it takes even longer because there's more onto that, okay? We need to do, after here, you will need to do the HTTPS handshake as well, which is some other few round trips. So each one of those adds up, right? So we are actually, this is actually taking some time to allocate those things. So this is one of the first problem of allocating sockets, allocating a new sockets. Then there is the problem of the TCP congestion window. So when we create a fresh new socket, you see when you create a fresh new socket and we do a get of something, it will return and it computes the response. It will start returning it in chunks. Okay, However, the window, we call this the TCP window. Okay, so this is the maximum amount of data that can be sent for each one of the round trips. For each one of a round that can be sent before receiving an ACK. Now, this is impacted by the reliability of the link and the fact that we are losing packets. Overall, over time, this value will reach to the maximum amount of bandwidth that can be supported over that TCP link. I don't want to enter to the algorithm; it's a little bit too complex. But the net result with this over time, by reusing the same connection, you could actually transfer all the response in one single block, shortening significantly up the response time. Note that to send the same file if our window was bigger, this will take just 96 milliseconds versus 264. So it's actually significant. Now, did all of this to say that to ensure the lowest latency, we must reuse the existing connections. So how do we reuse the existing connections with Node.js? Well, you can use an HTTP agent. How do we do that? Well, we create new HTTP agent, we set it with keep alive true, and we configure it with the number of the maximum amount of sockets with the maximum amount of with the number of connections. So we say you can use up to 1,000 connections, up to 100 connections, up to 10 connections, whatever you want. Really, it depends on your application. It's also very useful for TLS connections because with TLS you can actually it can actually avoid all that handshake as well. It's not set in by default. You need to configure it manually. So do it essentially, and it's extremely useful. These also avoid the problem of you exhausting the connections. So you can actually limit the number of maximum amount of connection in a socket in a process that you were going to use for something, so that you don't exhaust them. It's a common problem in applications where you might not have configured enough sockets in. You might exhaust the sockets that are available for your process in a real application. Normally, when you're running a node process within a container or something, you get, I don't know, 1,000, 220, 256, 1,024, or some numbers like that, number of sockets. So you see that's, you can't create one. If you want to create one more, you need to wait for a previous one to finish. So it's probably better just to use an agent and do this programmatically. Now, let's see if how this matches reality. So let's do a very synthetic benchmark. And we have a client that calls one server with 500 parallel requests, and then the target service takes 10 milliseconds to process the request. And the client has a limit of 50 sockets. So all of this is to say that this measurement is completely synthetic, completely meaningless to some extent. You need to benchmark these changes on your own systems, okay? Always measure, always measure. This diagram speaks it all, okay? Essentially, if the difference here is on the number of requests per second versus using an agent versus not using an agent, it's staggering. And you can see that the number of requests per second is so much more and on using an HTTP agent that if you're not using one, you should start now. So what do you do after you finish watching this talk? You go in and add a PR to your code, adding an HTTP agent. Cool. Okay. Can we improve things in this world? Oh, maybe. Okay, let's talk a little bit about HTTP pipelining. HTTP pipelining is a technique that you should not be using, or more or less. Slightly. Oh, what's happening? Ah, sorry, I don't know why that started. Okay, it's an HTTP that you probably should not be using. So what you can do is because one of the things that the browsers do not use. It's a feature of the browser that the browser does not use. However, it's a key. It's actually a very great. Um, it's actually a very good technique to speed up your servers. So it was actually very worthwhile checking if we can actually use HTTP pipelining. Now, be careful that HTTP pipelining, in order to use HTTP pipelining, what does this mean? Well, it means that you need to send from the client, you can send two requests at the same time. So you can get two files. And the server can actually compute those in parallel. And then send them back one by one in order. The key part is that they must be received in order. Now, this means that it suffers from head offline blocking. What does this mean? Well, it means that if the first request is taking too much time and the second one is ready, the second one needs to wait, increasing the server memory consumption. So that means that a slow request can stall the pipeline. Nevertheless, this is a great technique for server-to-server communication. So you can actually leverage, if you could leverage and use this, you can actually have a better usage of those pipes, of those sockets, and provide a better improvement inside your things. Note that head offline blocking is a problem, especially a problem in lossy networks. So especially from a client to the server, if you start losing packets, this is pretty bad. However, the links in your now data centers and stuff are really reliable, so that's not going to be a problem for our use case, but your mileage may vary, so please check in. So we have seen what does this matter to the, why does that matter to the HTTP pipelining matters with the Node.js event loop. It's pretty good to have a little bit of a refresher on how the event loop works before the next session with next block of slides. So let's go through it in a second. So you have your JavaScript, right? Your JavaScript, what your JavaScript do, it's there, and it's set up some IO. In that sense, it can, tell the server, please start listening for a socket, or open me a file, or do something. Now, it start doing that, it goes into the kernel to do this thing, or the thread pool, whatever. Then whenever that thing is completed, is being brought back into an event queue. From there, one at a time, it goes back into JavaScript and back into being executed. So this means that before receiving the next event, processing the next event, we need to be finished this one, right? In other terms, let's go what happens in the transition phase. So when you are receiving a data, this is your event loop. So the event loop has some events to process. It calls a callback that goes into C++. This is as done by libuv. The event loop is libuv. This is C++, stays in Node.js. Node.js call a JavaScript function, which in turn will call your code. After that's done, it's after that's done, okay, you can in here you can schedule some next tick or resolve some promises. After that's done, it goes back to C++, start processing the task queues of the tasks that were created before, the next tick and the microtask, and finally it goes back to the event loop. Note that all the time in which all the time from which we went into C++ to when we finished that C++ execution, in all that time the event loop was blocked. We are not processing any more IO events here. We are only executing JavaScript code. So the only way in which we can speed up our execution of some JavaScript is by reducing the time that it takes to do this loop. So how that goes into our microservices scenario? Well, it goes because if we want to increase that pipeline, we need to be faster. Like we need to essentially reduce the time we're executing JavaScript, which means making JavaScript code run faster or run less JavaScript. if you want to increase the throughput of Node.js, we need to minimize that every time the event loop is blocked. You can use Flame Graph to do that. There is a tool called Clinic that does this for you. There's a tool called 0x. There is a lot of tools for doing Flame Graphs for Node. So just pick one and use it. So these will increase the performance of your Node.js application. Be careful that. So another little thing that we need to know is about timeouts and decon resets. So reusing the connections means that you can or you could get into timeouts. Okay, so one thing that you need to keep in mind is that there is a keep alive. When you do keep alive, you might add an increased amount of timeouts due to the fact that the socket might be dead when it gets reused. So this strategy is we did a change recently in Node 15.6.0 and forward that the new scheduling strategy will be LIFO instead of FIFO. LIFO means last in, first out, and FIFO means first in, first out. So with a LIFO strategy, we are actually reusing the younger socket, the socket that was the least used. These will have the chance of increasing the bandwidth of that socket. That's nice. And also reducing the amount of possible timeouts. What will happen? One of the problem here is that it will increase the amount of times of socket that timeouts. So anyway, but those sockets will not be used, so it's okay. Anyway, use this LIFO scheduling if you experience econ resets. Now, let's go and talk about the new thing and how we can not double but triple the performance of the HTTP of doing HTTP 1.1 in Node Core. Let's introduce to Undici. Why Undici? Well, Undici is an homage to the fact that it's called HTTP 1.1, which is 2 ones, so 11. 11, it's also the very popular character of a Netflix series, Stranger Things. And the Netflix guys gifted me I don't have that anymore, but once I wrote this library, they have gifted me some swag from Stranger Things at a conference, so I had it in front of me, but the name 11 on npm was taken, so I went for the Italian, which is Undici. Hey, that's how it worked. So you can see that it's truly Stranger Things found down here. And by the way, this thing with all these like these things here can be actually the pipes of our clients. So anyway, how does Undici work? In Undici, what you can do is that you can have a request method. This request method can actually be used to perform an HTTP request. Can also be used a post, by the way, all those things. And then you can get out of it, you can get a status code, headers, trailers, and body. What are a lot of people ask me what are trailers? Trailers are HTTP headers, but after the body is received. So these are useful. Certain server will use them to include, for example, some computed value or an e-tag from the body or stuff like that. Anyway, most of them don't use it, so you can probably skip the trailers bit. What will happen is that you can process the request using for-await, which is the new nice async iterator syntax. So pretty easy. And then you can get the status code and the headers. It's nice. Okay, it's a nice thing to use. It also does keep alive by default. You can configure how many sockets, everything. You can do LIFO scheduling. It has no pipelining by default, and it has a limited number of connections by default. So it's actually a very good, nice global client to use. But you can also configure it. So you can also say, I want to use HTTP pipelining, for example, running 10 parallel requests at any given time and setting that 100 connection for each domain. And it will just use it. It's great. You can also destroy it, the agent, if you want to, and so on. So it's nice. Know that agent API is actually very high level. You can also go down several levels on the stack. So you can actually allocate a pool of connections and specifying a base URL and specifying the pipelining and connection objects and do HTTP requests. Or you can even go down and map to one single connection. And with one single connection, you can even do very lot of different interesting things to actually make things fast and speedy. And for example, you can even do a call where you actually pipe results directly to a stream in the end. So it's a very nice client to work with. It's not high level, it's low level, so it's a full replacement of what Node Core does. So, so how is Undici? Is Undici fast? So it's very interesting because you can see that Undici with pipelining is actually really fast. So I would actually recommend you checking these out. It's really nice and I really like it. So pipelining will actually increase your HTTP performance quite a lot. So check it out. I've done some benchmarks between this over a library called Fastify HTTP Proxy, which is from the Fastify framework. It's a web framework that I co-maintain. So hey, please check it out. What I've done is done some checks of some proxying, and I've seen that Undici beats Node Core proxying as well as it beats HTTP 2, which sounds weird here, and there is probably some optimizations that can be done to HTTP as well if we could. Anyway, I hope you have enjoyed this talk. Make sure to always use an HTTP.agent, and maybe check out Undici. Big thanks to Robert Nagy for keep up and doing such amazing work on the library. It's fantastic. Also thanks to Ethan and a few other folks that are working on this, that have started working on this. Thank you very much. It's so great to see progress on this library. We need help. So please, reach out, open issues, look at good first issues. It's really interesting, and it's actually making a lot of progress very quickly. So check us out. I just want to recommend this book. Is High Performance Browser Networking by Ilya Grigorik. It should be part of most curriculum in web development, but you should be really checking it out. Check out Fastify, is the web framework that I co-built. And here is Undici, which is the library we've been talking about for all of this. So thank you very much. I am Matteo Collina, and I work for Nearform. And yeah, that's it. Thank you for your time. Bye.
Matteo, thank you very much for delivering that talk at this year's conference. It was chock full of insightful and useful tidbits that our audience can take away. More excitingly, we've got a new HTTP client to play with in Node.js. Can I get a whoop whoop? Admit it, no one did that. Please do join me in giving Matteo a huge round the world round of applause. Our Q&A with Matteo will be starting any moment now over on the GatherTown platform, so please do get your questions at the ready and join us there. We would love to get some input from you. Not on GatherTown, not a problem. There's still enough time for you to grab a last-minute ticket so you can take part and get the most value out of this conference, but we are more than happy for you to post along on social media using the hashtag CityJS2021, as well as post along on YouTube in the comments section. See you in a minute for the next talk. Matteo, what a fantastic talk. Thank you for delivering it as part of this year's conference. Another superb session from yourself. An extra little round of applause from me to you.
Thank you, Tony. Thank you. I was very excited to deliver this talk at CityJS. It has been amazing, and thanks you for letting me in. I'm really I have. The funny bit is that I would really love to attend a live CityJS. So at some point, I never attended one for a lot of reasons. So I can't wait to be back in London for a conference. So
you and me both. This is the second one I've hosted, and I've never been to one.
Yeah, exactly. I don't know. I'm really feel that we are all live on Zoom now. We are all digital squares on other people's computer. I don't know. It's I miss the crowd, to be honest.
Yeah, you and me both. It's different giving a talk online, particularly when it's a pre-recorded talk and you don't get that feedback from the audience. It is completely different, definitely.
Yeah, it's a completely different experience. You can the good thing is that you can present your ideas and your things to much a wider audience, and the cost in terms of time for the speaker to attend to an event is way lower at this point.
Very,
So
very true.
it's a different world.
It is, but your time is still valuable. So I feel like we should fire some questions at you and wring a
Yay!
little bit more value out of it. And apologies for the additional cat there. So we've had a question come in from Andre, and it's I don't know. I think this might be one you get quite a lot. To what degree can this library package framework be used as a drop-in replacement to built-in HTTP module within Node?
It's not. It's not a drop-in replacement. It's a completely different API for good reason. The current the system, it was um, uh, designed with a lot. It was essentially it grow with Node.js, and it evolved from the in the early days of Node.js. And however, because of Node.js massive success, we could not change that. And we have like seeing the type of bugs and the type of problem that were part of that code base, we started working on Undici to address those problems at the core level. So it's not a one-to-one replacement. It does not offer the same API. And offering the same API would be a problem. So don't expect it to ever be that way. However, it will provide you slightly different APIs, which will probably be better for you, and it will be easier for to layer up another more simpler tools or simpler things on top. So it's yeah.
Okay. So, Undici, where did you get the name from? I assume that has a meaning in Italian. I probably missed it on the
Yes.
talk.
You missed it on the talk. It was very well explained. You didn't watch it closely, Tony. It's Undici comes from the fact that the Node Core HTTP library speaks about is about HTTP 1 and 1.1, and 1.1 are two ones, so it's 11. Also, at the time when I started working on that library, there was it was the hot thing of Netflix was Stranger Things. So it's and and the protagonist in Italian, the Italian translation is called Undici. So it's totally a Stranger Thing reference.
Okay. Okay. I've never seen Stranger Things, which is probably why I didn't get the reference, I guess.
You probably didn't get the reference, so
Ah,
that's why. It's
that's a
called
little
11 in English, the girl, and it's L, whatever.
okay. So we've got an actual proper question here from our audience, and I think you might like this one because it dives into the under the hood of your Undici. Even if I use connection reuse and pipelining, Undici is still faster than HTTP client. What is the secret sauce that makes it faster?
Okay, so there are a few interesting things. Um, uh, a huge amount of the complexity in Node Core HTTP client came from how the agent system is implemented. So on how connection are being reused. That does not that's not efficient essentially. In order to make it efficient, we will need to rewrite and change all the APIs. So and we'll be back to square one. So it's not like that API. It will be very hard to make that API efficient, and that's mainly that's a huge part of the reason. There are other reasons. So the way Undici is layered, so that it's you need to consider there are multiple layers in the stack. So there is the networking layer, there is TLS, which more or less is very similar to networking in terms of APIs. Then we have HTTP. The way HTTP worked in Node Core, it was built as a layer on top of those things. And while Undici just uses those low-level components. So essentially, it has the performance of a raw, if you very similar to how you would use the internal net or TLS modules instead, without having to pass through some other proxy to get those data. So that essentially the reason. You see the difference because in Node Core, you have that you call, when you do a request, it returns an outgoing message object that then you write things to. And that API does not exist in Undici. You pass in what you want to write to Undici, and it will write it to a socket, essentially. That's the key difference between the two approaches. So, and that's where most of the speed come from.
Okay. So it sounds like it's you've kind of taken a different approach then. Is that right to say?
Totally different approach.
Yeah. And that's where your gains come from. Fantastic.
Yeah.
Just goes to show you, if you think differently, you get amazing results, right?
Yeah, well, so it's not just thinking differently. I have seen, so all of the design of that library came from a live system. So I've seen what was the pain points and debugged Node.js based application at scale, see what were the pain points, where time was spent or time was lost there, and optimizes those cases.
Fantastic. Brilliant answer, by the way. So we've got one from George now. Can you offer some perspective as a TSC member on why more performant defaults for Node are not added?
So this is an interesting question. Most of this comes from backward compatibility. Okay. So it's the key problem we have in Node is that there is a massive amount of installed libraries around the world, or installed Node installation, and we can't break them. Especially this is the biggest issue. And especially on HTTP, there are two big problems. The first one, it's that we have the first one is that we have both the server and client implementation that use the same base classes. And you might wonder if some of those performance issues are still present in the server. Yes, they are. Okay, so we potentially could improve the server as well, might do in the future, but the server is mostly fast enough at this point. And there is the server and the client, and they share some common data structures. Those are the data structures that are problematic. On top of that, on the server side, we have libraries like Express and Restify that monkey patches core to work. So we can't even change those internal data structures. So a huge amount of the Node.js HTTP stack has been frozen in time. At the time of 0.10, 0.8, there was a lot of things that were changed, minor, but not a significant amount.
Okay. Sounds like a right headache to decide whether to introduce something or not.
Well, it's possible to introduce new things, okay? However, if we are introducing them in core, then they will become a maintenance problem very quickly. Yeah. So instead, the approach that we have taken with Undici is to develop this in the ecosystem on npm, so that by the time we add it to Node Core, it would be done. Like we can iterate on a very powerful design before having some huge maintenance burden that brings to be a Node core, essentially.
I mean, that sounds like the perfect question. Answer to that question. Thank you for sending that one in. We've got one here, and it'll have to be a quick answer because I want to get to our rapid fire questions. And this one comes from Andre. How do you measure a flame chart on the server? Brackets, browser has DevTools.
First of all, you can actually do the same thing that a browser do. You can just connect DevTools to your Node.js server. There is another thing that we have developed at Nearform called Node Clinic. Is actually clinicjs.org. You can find it, and that will give you all the tools to make some informed decision.
Okay. And just as a follow-up question, you mentioned Nearform there, and I see you're badged up as well. Well done on having the right logos, by the way. Is Undici a Nearform project?
No, it's not. It's a Node core project. It's
okay.
It was a Matteo project, but that was born from Node. I started this sitting on the couch on an evening, essentially. That was my thing, but that's when I started it. And then while watching Stranger Things, and that's exactly how it started, by the way. And then I let it sit for some time. Then we were discussing with the other Node core collaborator. They were having some frustration with the Node core HTTP stack. And then we started, they said, well, there is this thing that I've developed is a new library. And Robert Nagy started contributing heavily to it. And then I essentially donated it to the Node.js project. So now it lives into the Node.js organization and is Node.js/Undici. So it lives there, and it's maintained by a team now. So it's essentially, I'm mostly doing code reviews at this point in time and helping out with some QA work, essentially. So, but it's really great, and I'm very happy that those designs that I did a few years back are actually very giving their fruits now. So there is a lot of companies using it in production right now.
It's perfect. And I'm sure all of those companies using it in production are going to have pull requests for new features and things like that coming.
Yeah, there is a lot of traffic on the repo. Like if you open it up, we are actually going very soon going to ship a new major version, which will include the redirect handling. It will include a mock. It will include a mock system, and then it will have the HTTP parsers that will not use the one from Node Core, but will use it won't use the same one from Node Core, but it will use it will still use LLHTTP, which is what Node Core uses, but instead of getting it from the Node Core binary, it will load it from WASM, WebAssembly. And the reason for that is that it's pretty great, and it will make sure that we have a consistent implementation across all Node versions.
Perfect. So we've only got a few seconds left. So I've got some rapid fire questions to wrap up before we say goodbye. So the first one, tabs or spaces?
Of course, spaces.
Good man. Good man. Front end or back end?
Back end all the time.
Really?
Oh, yeah, of course.
That's your specialism, I guess.
Yeah, that's it.
TypeScript or JavaScript?
Of course, JavaScript all the time.
Good man. Good man. 2 out of 3 question answers there were right. So we'll let you pass on that. Matteo, it's been a pleasure to talk to you again. Thank you very much for being a part of this year's conference.
By the way, Tony, Emacs or Vim?
Vim.
Yeah, you see, you got the right one.
I mean, I'm still stuck in the same Vim terminal I was 10 years ago, but
yeah, of course.
And on that note, we will leave you there. Thank you very much for tuning in.
Bye. Bye.